let's get started on lesson 6. You're going to start by just taking about a minute, and I want you to just write one thing you notice and one thing you wonder about this graph. Okay, so let's go over some of the things you could have noticed or you could have wondered, starting with our notices. You do not have to write all of these down. I just hope that you notice something along the lines of what I have. So hopefully you notice that the graph is about pages read each day. We see that on our X and Y axis. No, they didn't give us a situation for this, but we could gather that from what they tell us on the graph. So number of days is on the X axis, number of pages read on the Y. We can also see from this that the same number of pages were read each day. So we see that it's going up at a constant rate. So that's why we know that. It's going up at a constant rate. It's a straight line, so we know that they're reading the same amount of pages each day. We can see that on day 4, 160 pages were read, according to this graph. And then I hope you all noticed what we've been looking at and what we've been seeing is our proportional relationships where they all start at 0, 0 and continue up. This graph does not start at 0, 0. It actually starts at 0, 40. That's what that point is, 0, 40. So we would say the number of pages read doesn't start at 0. Now that we have our notices, let's talk about maybe some, we are wondering about a few things now. So let's see what our wonders could be. Again, doesn't have to be exactly this, just needs to be close. Hopefully you're thinking something of this. Okay, so one wonder we may have is why doesn't the number of pages start at 0? What are the 2 dots on the graph 4? And then you may be wondering how many days it would take to read X amount of pages. So maybe 300 because we can't gather that from this graph. So maybe we're wondering how many days to read 300 pages. All right, so now that we have that, let's go on to 6.2. All right, we're going to read this situation 3 different times, and each time I'm going to ask you a few questions that you can be thinking about, and then, of course, I'll answer them for you, and then we'll get to answering the question. So it says, Lynn has a summer reading assignment. After reading the first 30 pages of the book, she plans to read 40 pages each day until she finishes. Lynn makes the graph shown here to track how many total pages she'll read over the next few days. After day 1, Lynn reaches page 70, which matches the point 170 she made on her graph. After day 4, Lynn reaches page 190, which does not match the point 160 she made on her graph. Lynn is not sure what went wrong, since she knows she followed her reading plan. Why doesn't Lynn's reading progress match her graph? So think about, what is this situation even about? What are we thinking about here? So take 30 seconds and just think, what is this situation talking about? Okay, so hopefully you realized that this situation is about a girl named Lynn, who made a graph to track the number of pages she read during a summer reading program. That's what this whole situation is about. So let's read it one more time. Lynn has a summer reading assignment. After reading the first 30 pages of the book, she plans to read 40 pages each day until she finishes. Lynn makes the graph shown here to track how many total pages she'll read over the next few days. After day 1, Lynn reaches page 70, which matches the point 170 she made on her graph. After day 4, Lynn reaches page 190, which does not match the point 160 she made on her graph. Lynn is not sure what went wrong, since she knows she followed her reading plan. Why doesn't Lynn's reading progress match her graph? So something else we can be thinking about is what quantities can be counted or measured here. So I want you to take 30 seconds and think about, what things can I count, or what things can I measure, or maybe it's a little bit of both. Okay, some things that can be counted or measured. We know that she's already read 30 pages, so maybe we should underline that. We know that she's going to read 40 pages each day. And then after day 1, she's on page 70. And she uses 170 to represent that on her graph. And after day 4, she's on page 190. But her point does not match that. So now we're going to read it one more time, and then we're going to get to actually answering the question. This is just a good strategy to use whenever we have a bunch of reading to do in a math problem and numbers attached to it. It's a good strategy to read it more than once and think about, what is it about? What are things I can count or measure? Okay. Lynn has a summer reading assignment. After reading the first 30 pages of the book, she plans to read 40 pages each day until she finishes. Lynn makes the graph shown here to track how many total pages she'll read over the next few days. After day 1, Lynn reaches page 70, which matches the point 170 she made on her graph. After day 4, Lynn reaches page 190, which does not match the point for 160 she made on her graph. Lynn is not sure what went wrong since she knows she followed her reading plan. Why doesn't Lynn's reading progress match her graph? Well, if we wanted to, we could help answer this question by maybe sorting our information into a table. So that's what I'm going to do. I'm going to start by making a table. This is going to be number of days. And this is going to be pages read. Now, if you remember, this is a summer reading program that she is getting ready to start. So before Lynn even starts the reading program, so day 0, she has already read 30 pages of the book. So here, we wouldn't have a 0, 0. We would have a 0, 30. Then she says after day 1, she is on page 70. After starting the reading program, she's now on page 70. Day 4 of the reading program, she is on page 190. That's all the information we were able to take from this situation. So now what we can do is we can take this information and compare it to our graph. So we said before she even started the reading program, she had read 30 pages. So that means my line should start at 0, 30. And we see that our line actually starts at 0, 40. And then from there, she goes to 170. And then to 100. So let's think about this now. So day 0, she says she started at 40 and went to 70. So from 40 to 70, that is a 30-page increase. So they're saying she's actually, if we look at this graph tells us that someone started at page 40 and increased 30 pages each day. That is what this line is showing us. So because of that, it is not matching Lynn's progress. Okay? So what that means is we can now, because this line right here is telling us that someone started day 0, they've already read 40 pages. So by starting the reading program, they're already 40 pages in. Day 1, they read 30 more pages. They get to 70 pages. Day 2, 70 plus 30 is 100. So day 2, they're at 100 pages. 100 plus 30 is 130. So at day 3, they should be at 130 pages, which they are. So this person is not Lynn. Lynn messed up her graph because she started at 40 instead of starting at 30. And then she increased by 30 each day instead of increasing by 40 each day. So we would say, to answer this question, we're going to say that the initial amount read, 30 pages, and how many pages she reads each day, 40 pages, is switched on the graph. So we just said that this line starts at 40 and increases by 30. It needs to start at 30 and increase by 40. So we are going to show a graph that actually does this. And we have that information right here. So we're just going to take this information from our table and plot it on this graph correctly now. So 0, 30, 0 up to 30 is here. 170 is here. It's already plotted for us. That's the one point they have in common. So on day 1, they have the same amount of pages read. And then for 190, this is counting by 20s. So 160, that would be 180. So that would actually be up here a little bit. But we could also include in here day 2. So 70 plus 40 would be 110. So day 2, 110. And then we can connect our points. So using a ruler or a straight edge, we are going to connect these points. So every time here, how my y is changing is it's increasing by 40 each day. So every day we are adding 40. That is my rate of change. And we see that here, 40 pages each day. That's my rate of change. So we've talked a lot about rate of change up until this point. We know that the rate of change can also be the slope. So this is also considered our slope, the rate of change. But a new term that we have now is called the y-intercept. So we actually have 2 y-intercepts on this graph. Only one is correct, but we have 2. So the correct y-intercept is this one right here. The y-intercept is where my line crosses through the vertical axis or the y-axis. This can also be called the vertical intercept. So it's where it passes through. It intersects or intercepts through the vertical or y-axis. We call that a y-intercept. We are getting ready to get into writing equations for certain situations. I can write an equation that represents this situation. And it looks a lot like the form of y equals kx. Only now instead of y equals kx, it's going to be y equals mx plus b. Where instead of k next to our x now, we have m that represents the slope. And our b represents our y-intercept. So if I wanted to write an equation for this, I know my slope is 40 because that's how it's changing each day. It's my rate of change. So my rate of change is always my slope. So I can take out m and replace it with 40. And then add the 30 pages already read or the y-intercept. And x represents my days and y is total pages of read. So I can plug in for any number now for x, and it will give me how many pages I will have read if I stick to this plan. We are going to get some more practice with this on our next activity, the cart sort. So let's go on to 6.3. Okay, so 6.3. we have 6 situations and 6 graphs. So we're going to be matching a situation to a graph. Okay, that's what we're going to do here. And then we're also going to be writing an equation for each situation. So if you remember from 6.2, our equations are going to be in the form of y equals mx plus b, where m is next to x. So instead of k, we have m. M is our slope, and b is our y-intercept. So that's important. Where my line passes through the vertical intercept or the y-intercept, that's going to replace b. Whatever my slope is, that's going to replace m. Okay? So let's start by reading some of these situations. It says Lynn's dad bought a tablet. He pays the same amount each month for a subscription to a movie streaming service. The graph represents how much money he spent Y for the tablet in X months of service. The slope of the line is 10. So the only number they give me in this situation is the slope. Situation B. The graph represents the perimeter Y of a square whose side length is X. The slope of the line is 4. So again, they give me the slope. Situation C. Diego puts his piggy bank on his desk. Each week, he adds the same amount of money to his bank. The graph represents the amount in the piggy bank Y after X weeks. The slope of the line is 5. So again, they give me the slope. Situation D. Noah starts his piggy bank off with money he saved helping a neighbor out. Each month, he adds the same amount of money to his bank. The graph represents the amount in the piggy bank Y after X months. The slope of the line is 15. Again, they give me slope. Situation E. Elena adds a quarter to her piggy bank every day. The graph represents the number of dollars Y in her piggy bank X days after she puts the piggy bank in the closet. The slope of the line is 2,500. Lynn's mom pays the same amount each month for internet service for her business tablet. The graph represents how much money she spent Y for X months of service. The slope of the line is 40. They give me the slope every time here. So it looks like I'm going to be calculating the slope of each of these situations. So let's do that. So starting with graph 1. So on graph 1, I know our graphs are a little spotty. Okay, you don't have to tell me that. I know that. So on graph 1, we need to find 2 really good points. So remember, good points is where my line intersects, passes through an intersection. So a good point would be here, and another good point would be here. So what I'm going to do is I need to find the vertical distance and the horizontal distance. But what I have to pay attention to are my scales. So for my vertical distance, if I come over here, it looks like I'm counting by 5s. 5, 10, 15, 20, 25. So that means every 1 is 5, not 1. So my vertical distance here is 5. Now I need to find my horizontal distance. Well, looking down here, my scale is counting by 1/2. So for every 1, that's really 1/2. So this is 1/2 and 1. So to find the slope, I would say vertical distance divided by horizontal distance. My vertical distance is 5. My horizontal distance is 1. So if I type that in my calculator, 5 divided by 1, I'm going to get 5. So my slope for this situation is 5. So let's go back to our situations that we just had. And we need to find the situation where our slope was 5. So that was situation C. So we're going to write situation C because it had the slope of 5. And now we're actually going to write an equation for this in the form of y equals mx plus b. This is called slope-intercept form. So I'm going to take out m, replace it with the slope 5, and take out b and replace it with our y-intercept. And that is where it passes through the y-axis. So we would say y equals 5x plus, and it passes through right here at 0, 10. So we'd say plus 10. So this tells us that Diego originally had $10 in his piggy bank, and then he puts $5 in his piggy bank each week. All right, let's do the next graph together. Okay, it's actually graph 3, so we're just going to move on over to graph 3. So for graph 3, we are going to plot 2 really good points. So I'm going to plot one here and let's see here and right here. I'm going to draw my slope triangle. I have a vertical distance and a horizontal distance. That's how I find my slope. But I have to pay attention to the scales. So my x scale, my horizontal scale, is counting by halves again, because there's one right here without a number, and then it goes to 1. So this is actually counting by halves. And then my vertical distance, or my vertical axis, is actually counting by tens. They're skip counting every other tick mark, so we have to include this one. So that's 10, 20, 30, 40, 50, 60, and so on. So they're counting by tens. So for my horizontal distance, every one is a half. So half, 1, 1 1/2, 2. My vertical distance, every one is actually 10. So 10, 20, 30. 30 divided by 2 is 15. So my slope here equals 15. So we need to go find a situation where the slope is 15. And we see that is situation D. So situation D says Noah starts his piggy bank off with money he saved helping a neighbor out. Each month he adds the same amount of money to his bank. The graph represents the amount in the piggy bank. So now we're going to write an equation in the form of y equals mx plus b, where m is my slope, b is my y-intercept, to represent this situation. So we know each week he adds $15 to his bank account. That's my rate of change. Every week he's adding the same amount, but he started with $40 in his bank or in his piggy bank. So our equation for this situation would be y equals 15x plus 40. $15 every week is the slope. $40 is what he started with. That's his y-intercept. Okay, let's do the next graph. Graph 5. I need to find 2 good points. There's one here and there's one here. I'm going to make my slope triangle. I need to determine what we're counting by here. So x's, we're counting by ones. My y-axis, I'm also counting by ones. That's nice. So this is 1, and this is 1, 2, 3, 4. So I'm going to do vertical distance divided by horizontal distance. 1 divided by 4. That's 1/4, or we have 25 hundredths. So this is my slope. So we need to find a slope of 1/4 or 25 hundredths. And if we look at our situation page, that would be situation E. Elena adds a quarter to her piggy bank every day. The graph represents the number of dollars Y in her piggy bank X days after she put the piggy bank in the closet. Okay, so again, we're going to write an equation in the form of y equals mx plus b, where m is my slope. I already know my slope. I know it's 1/4 or 25 hundredths. You can use either of those. I'm going to use the fraction. Plus the y-intercept. That's what b is. So where does my line pass through the y-axis? Passes through at 9. So let's talk about what this equation means for that situation. So we know that Elena adds a quarter to her piggy bank each day. That's the slope. That's the rate of change. So every day her piggy bank is increasing by 25 cents. Well, her piggy bank must have started with $9 before she started adding the quarter to her piggy bank. So the 9 tells us where she started, or what she started with. The 1/4 tells us how much it's increasing every day. Okay, let's go to graph 6. We're going to find the slope of this graph. To find the slope, we need to find 2 good points. So I'm going to plot a point here and plot a point here. Then I will make my slope triangle. My x-axis is again counting by 1/2. It's important to pay attention to your scales. My y-axis is counting by 5s. So this would be 5, 10. And this would be 1/2, 1, 1.5, 2, 2.5. So now I have to do vertical distance divided by horizontal distance to find my slope. 10 divided by 2.5. And I get 4. So which situation represents that? I don't think we did. We need to write situation E on this one. Sorry. So situation B has a slope of 4. The graph represents the perimeter y of a square whose side length is x. The slope of the line is 4. So we're going to write situation B here. Now let's write an equation to represent this. So again, it's going to be in the form of y equals mx plus b. M is my slope. Every time, I'm going to take out m and replace it with 4. Y equals 4x plus b is the y-intercept. Well, our y-intercept here looks to be 0, 0. So y equals 4x plus 0. This is actually a proportional relationship. Okay, graph 2. Find 2 good points to find our slope. I'm going to go here and here. My x is counting by 1/2. My y is counting by 5s. So this would be 5, 10. Vertical is counting by 5s. Horizontal is counting by halves. So this would be 1. Vertical distance divided by horizontal distance. 10 divided by 1. That's 10. So which situation has a slope of 10? And that is situation A. Lynn's dad bought a tablet. He pays the same amount each month for a subscription to a movie streaming service. The graph represents how much money he spent, Y for the tablet, and X months of service. So now we're going to write an equation in the form of y equals mx plus b. M is my slope, so take out m and replace it with 10. B is my y-intercept, so take out b and replace it with where this line passes through the y-axis, and that would be 40. So this equation tells us that he paid $40 for the tablet, so that's $40 for the tablet, and then he pays $10 each month. So by filling in this equation, he can find out how much he's total spent on this tablet and subscription. So now let's do the last graph. Graph 4. We need to find the slope. So I'm going to put a point here and a point here. And I need to find my Vertical distance divided by horizontal distance. So my X is counting by 1/2. My Y is counting by 10s. 10, 20, 30, 40, 50, 60. 1/2, 1, 1.5, 2, 2.5, 3. So we're going to go vertical distance is counting by 10s. So 10, 20, 30, 40, 50, 60. And then my horizontal distance is halves. So that would be 1/2, 1, 1.5. So then we're going to do 60 divided by 1.5. And we get 40. So the last situation with a slope of 40 is situation F. And it says Lynn's mom pays the same amount each month for internet service for her business tablet. The graph represents how much money she spent. Y for X months of service. The slope of the line is 40. So now we're going to write an equation in the form of Y equals mx plus b, where m is our slope. So we're going to take out m and replace it with our slope, which is 40. So y equals 40x. B is my y-intercept. So it actually starts at 0, 0, so plus 0. This is also a proportional relationship. So her tablet and internet service must be included in the payment. Okay, that is all for this lesson.